Alright, so here's the Rolle's theorem. Again, this is just a special case of the mean value theorem. The mean value theorem, remember, just told us if there's a slope between 2 points on a continuous function, that somewhere in between there must be a tangent, at least one point that has an equal tangent slope. Well, now all we're saying is that what happens if those heights on the curve are actually 0? And I'll show you a diagram of this on the next page. Well, then the same thing is true. We can actually do that now. Before, we weren't really supposed to do that if they both equaled 0 or if they equal each other. But now we can. So, little history here. You could read that if you want. Let's go on to the next page. So, here's some conditions of the Rolle's theorem. Here you could see both at a and b, the height of the function is both 0. So somewhere in between here, they must have a tangent slope of 0. Here, the heights at both a and b are the same, and so somewhere in between here, they must have a tangent slope of 0. That's all this is. So it's really the exact same thing as the mean value theorem. It's just that in this scenario, the tangent slope is 0, or the slope between the 2 points is 0. That's really the only difference. So let's go to the next page. All right, so first let's just check and see if it's a Rolle's theorem problem. I mean, if they say use Rolle's theorem, it pretty much is, but I just want to show you how we could check that. To check that, you have your a and your b, and you just plug them both in. So let's plug in a 0 and see if we get a 0. Well, this would be 0 squared over 2 minus 6 times 0. Well, sure enough, that's 0. And then we could check f of 12, and this would be 12 squared over 2 minus 6 times 12. And this actually, hopefully you could tell, but this is 144 divided by 2 is 72, and 6 times 12 is 72, and so this also equals 0. So yeah, it is a Rolle's theorem problem. So really though, if they would have told us it's use Rolle's theorem, then we could go ahead and assume that the f of b minus f of a over b minus a, we could just go ahead and assume that's got to be 0. All right. Well, if that's true, then we could just take the derivative of this. So let's just go ahead and take the derivative. I'm going to rewrite it first. So f of x, if I rewrote it so that I can use power rule easily, it'd be 1/2 x squared minus 6x. Therefore, the derivative would be 2 times 1/2 is 1, so this would just be x minus 6. Well, look, I'm just trying to figure out when this thing equals 0, right, from here. Well, that's pretty easy. It's got to be when x is 6, or we could say when the c value is 6, because they're asking specifically for the c value. That's all there is to it. Pretty simple idea. All right, let's go on to the next page. Okay, they say use Rolle's theorem, so we can go ahead and just make the assumption. You could check it if you want, but that means that f of negative 3 equals 0 and f of 3 equals 0. So let's go ahead and go right into the derivative. That's going to be a 2x. So all we're really saying is when does this equal 0? Well, that's when x equals 0 or the c value. Oh, sorry, my handwriting got weird. So it's just when c equals 0. Super easy, right? All right, last one here. I want you guys to try it on your own. Again, just pause the video, work it out, and then come back when you're ready to check your work. They do say use Rolle's theorem, so you could go ahead and just skip through this. Alright, so they said use Rolle's theorem, so I just took the derivative. That's 2x minus 8. I'm looking for when this derivative equals 0. That happens when x is 4, or my c value is 4 is really what they're going to ask for. Pretty simple stuff, guys. Hope you guys crush this skill on con. See you guys in class.